Let ABC be an equilateral triangle with side length 55. Points D, E, F lie on BC, CA, AB respectively, with BD equals 7, CE equals 30, and AF equals 40. Point P inside ABC has the property that angles AEP equal to BFP and CDP. Find tan squared angle AEP. So this is triangle ABC, which is an equilateral triangle with side length 55. I've drawn points D, E, and F on BC, CA, AB respectively, with BD equals 7, CE equals 30, and AF equals 40. We want to find the unique point P inside ABC with the property that angle AEP equals angle BFP equals angle CDP. That is, the angles I've marked in blue are equal. Notice I've marked an additional set of angles in green, which are 180 minus the angles I marked in blue earlier. A blue angle and a green angle form the opposite angles of each of the three quadrilaterals AFPE, BFPD, and CEPD, meaning that all three of those quadrilaterals are cyclic. Let's learn more about triangle DEF first. Let's apply the cosine law on triangle DCE. Triangle ABC is an equilateral triangle with side length 55, meaning all of its angles are equal to 60 degrees. So using the cosine law on triangle DCE, we get that DE squared is equal to 48 squared plus 30 squared minus 48 times 30. This is the special case for the cosine law with 60-degree angles. And that's 2304 plus 900, 3204 minus 1440, which happens to be 1764, or 42 squared. So DE equals 42. Using the same type of logic on triangles EAF and FBD with the lengths I've labeled on the sides of triangle ABC, we get that FE is 35 and FD is 13. Now we can simply remove P from the diagram and treat it as the intersection of two circumcircles. That is, the circumcircle of triangle BFD and the circumcircle of triangle CDE. The problem wants us to find tan squared angle AEP. However, this is none other than the tan squared of angle CDP, because the angles are equal according to the problem statement. This in turn is none other than the slope of line DP squared. So our eyes are set on finding the slope squared of line DP. And the slope of line DP is minus 1 over the slope of line OBOC, which are the centers of the two circles that I've labeled in triangle ABC. So to find the slope of DP squared, we'd have to square the expression on the right, which is just 1 over the slope of OBOC squared. To find the centers of the two circles, we introduce a coordinate system where B is located at minus 7, 0, D is the origin, and C is at 48, 0. Now we can drop two perpendiculars from OB and OC to the midpoints of BD and DC respectively. Let's call those midpoints MB and MC. Then MB is equal to minus 7 over 2, 0. That's the midpoint of BD. And MC is equal to 24, 0. These imply that OB is on the line x equals minus 7 over 2, and OC is on the line x equals 24. Let's now use the extended law of sines to find the radius of those circles. So we have that the radius of the circumcircle of BDF is equal to FD, which is 13, over 2 times the sine of angle DBF, the angle opposite FD, which is just 60. And that turns out to be 13 over root 3. The radius of the circumcircle of CDE, DE is 42, so it's 42 over 2 sine 60, which turns out to be 42 over root 3, which is just 14 root 3. Let YB be the y-coordinate of OB, and similarly let YC be the y-coordinate of OC. Then we get from the radius of the circumcircle of BDF, we have 7 over 2 squared plus YB squared is equal to 13 over root 3 squared, which is 169 over 3. And for the circumcircle of CDE, we got that its radius was 14 root 3. So 24 squared plus YC squared is going to equal 14 root 3 squared, which is 588. So we can find that YB is equal to the square root of 169 over 3 minus 7 over 2 squared, which is 49 over 4. And this is equal to the square root of 529 over 12, which equals 23 over 2 root 3, or 23 over 6 times the square root of 3. And we get YC is equal to the square root of 588 minus 24 squared, which is 576. That's just equal to 2 root 3. And so we can finally get the slope of OBOC. We have YC minus YB over XC minus XB. And that's going to be 2 root 3 minus 23 over 6 root 3 divided by 24 plus 7 over 2. This is minus 11 over 6 root 3 divided by 55 over 2. If you multiply both numerator and denominator by 6, you get minus 11 root 3 over 165, which is minus root 3 over 15. And we wanted 1 over that squared, so 1 divided by root 3 over 15 squared is 1 divided by 3 over 225. That's 225 over 3, which is 75. Thank you for watching, and please follow my channel if you would like to see more videos.